Institute of Technology, Solapur. Today's topic of the lecture is round robin scheduling. Let's proceed with the topic. At the learning outcome, at the end of this session, students will be able to solve problem based on round robin scheduling. CPU scheduling is the basis of multi-program operating system. So, multi-program operating system works based on CPU scheduling concepts. By switching the CPU among the processes, the operating system can make the computer more productive. So, what is the reason of making CPU scheduling? To make computer more productive. There are two types of process scheduling. One is primitive scheduling, another one is non-primitive scheduling. In case of primitive scheduling, one process is preempted and the preference will be given to another process based on a priority or based on the arrival time. In case of non-preemptive scheduling, one process is going to execute for its overall burst time. That process is not going to preempt in the middle. So, these two are the basic types of scheduling. Let's start with the round robin scheduling. The round robin scheduling algorithm is designed especially for time sharing system. It is similar to FCFS scheduling, but preemption is added to switch between process. So, the concept of round robin scheduling is similar to the FCFS scheduling, but preemption is added to switch between the processes. A small unit of time called a time quantum or a time slice is defined. Time quantum is generally from 10 to 100 milliseconds. A time unit is defined in case of round robin scheduling, and a time quantum range is from 10 to 100 milliseconds. To implement RR scheduling, we keep the ready queue as a FIFO queue of a processes. So, here we are using a ready queue and it works in the manner of FIFO queue of a processes. New process are added to the tail of the ready queue. So, here new process are added to the tail of the ready queue. The CPU scheduler picks the first process from the ready queue and sets a timer to interrupt after a one time quantum and dispatches the process. The process may have a CPU burst of less than one time quantum. In this case, the process itself will release the CPU voluntarily. For example, if you have defined the time quantum as 2 milliseconds, and if one of the process is having a time quantum of 1 millisecond, then that process is going to execute for 1 millisecond. After that, the process will release the CPU voluntarily and the preference will be given to the next process in the queue. The scheduler will then proceed to the next process in the ready queue. Otherwise, if the CPU burst of the currently running process is longer than one time quantum, the timer will go off and will cause an interrupt to the operating system. The context switch will be executed and the process will be put at the tail of the ready queue. If the time quantum is more than the assigned time quantum, then the process context will occur there and the process will be put at the tail of the ready queue. The CPU scheduler will select then the next process in the ready queue. So, here the CPU scheduler is going to select the next process in the ready queue. In the RR scheduling algorithm, no process is allocated the CPU for more than one time quantum in a row. So, at a time, only one time quantum is allocated for each process. If a process CPU burst exceeds one time quantum, that process is preempted and is put back in the ready queue. The RR scheduling algorithm is thus preemptive. So, here round robin scheduling algorithm is in the category of preemptive, where one process is preempted and the preference will be given to another process for execution. Let's solve a problem based on round robin scheduling. The given scenario is three processes are given, P1, P2 and P3, with their burst time is given. P1 is having 24 millisecond burst time, P2 is having 3 millisecond burst time, P3 is having 3 milliseconds burst time. Time quantum given is 4 milliseconds. Let's first solve this example with the help of the Gantt chart. Observe that P1 is the first process to start and the time quantum is 4 milliseconds. So, P1 is going to execute between 0 to 4 milliseconds. Observe that here P1 process total required time is 24 milliseconds. From that, P1 executed only 4 milliseconds. So remaining time is 20 milliseconds. So at this point, observe that next preference will be given to P2 process. P2 requires only 3 milliseconds, so P2 completes its execution within only one time quantum. P3, next process is P3. Observe that again P3 time quantum is 3 milliseconds, burst time is 3 milliseconds, so P3 is going to execute within only one time quantum. So here till 0 to 10, P1 executed only 4 milliseconds, P2 and P3 completed its execution. Next, the preference will be given to P1, and observe that here P1 executes in each slots row wise. P1 executes for 4 milliseconds only. So here total required time for P1 to complete is 30 milliseconds. Next is to calculate turnaround time and waiting time. The formula for turnaround time is completion time minus arrival time. Formula for waiting time is turnaround time minus burst time. Let's solve this example with the help of this table. Process P1, P2, P3 is given. Arrival times of all process considered as 0. Burst time is given as 2433. Completion time of process P1. So we can calculate completion time from the Gantt chart. Completion time of P1 is 30 milliseconds. P2 7 milliseconds. P3 10 milliseconds. Turnaround time is completion time minus arrival time. So from that you will get P1 turnaround time 30 milliseconds, P2 turnaround time 7 milliseconds, P3 turnaround time 10 milliseconds. Let's calculate waiting time. Waiting time is turnaround time minus, like it is a turnaround time minus burst time. So from that we will get 6 milliseconds for P1 process, 4 milliseconds for P2 process, 7 milliseconds for P3 process. Let's calculate average turnaround time and average waiting time. So in this example, the average waiting time is 5.66 milliseconds. The average turnaround time is 15.66 milliseconds. Just think and write. You can pause the video and try to answer the question. Let's go for an answer. Round robin scheduling falls under the category of primitive scheduling. So already we have seen in the video lecture that round robin scheduling prime the process. Whenever a process is having a time quantum more than one time quantum, the burst time of the process is more than one time quantum, then that process is preempted and it is executed in the second time span. That's why round robin scheduling falls under the category of primitive scheduling. References. Thank you.